Hello, everyone. Hello, everyone. Nice to see you all. I hope you get your coffee. So I drank coffee a lot today, just to be prepared. and as always, I just finalized my presentation like 30 minutes before the talk. So this is my style. But I hope you like it. Today we are going to talk about unstructured data management, right? We are talking about AI, LLMs, but anyway, all these AI initiatives, they are about data at the beginning, right? So we train with data, we validate with data, we actually generate predictions with data. So I'm right now a technical product manager at Nebius, and I'm working on tools for AI and ML developers that are available on our platform. And Nebius is an AI cloud that provides compute resources and tools infrastructure for startups and companies, mostly in GenAI. Like before this last 3 years, I was working with Iterative. It's a company that develops open source tools for AI and ML developers, like DVC, data chain. And today the talk will be about my previous research before Nebius, together with DVC. And we were working on a data chain tool that's specifically designed to manage unstructured data. So let's look on some trends that I think you are familiar with. That like there is some like rising trends of AI adoption in multiple industries, areas, and multiple applications. And this AI adoption actually is stopping with different challenges, and many of those challenges are about data. So lack of data and bad data quality, lack of skilled people who can actually take this data and prepare in the right format and build something on top of it, and actually like infrastructure. So with these trends and like AI trends and AI adoption, so on the data market trends, there's also a lot of changes. We try to develop AI-driven solutions specifically for data management, how to curate data, how to process clean data, and there are a lot of interesting solutions on the market. We generate actually a lot more and more unstructured data, text, videos, images, and all this like unstructured data that I use to train multimodal models. They require a bit like different approach and new tools. The old tools are not very convenient to deal with such amount of data and such modalities. So what is unstructured data? As we said, it's already these are like texts, videos, images, audio, so a lot of different formats that we need to process and prepare for AI training. And most of those data that are available right now for companies is text-based data, right? But if you take the internet, so like the majority of data, not majority, okay, 65%, more than half, is video content. So we generate a lot, and we can process it to train better models. And like a new tool specifically for these unstructured data pipelines arose recently, specifically for processing those data, for storing, for querying those data, etc., etc. And so when I was working at Iterative, so we decided also to move into this direction because like the data is a new oil, new gold, so we try to build some tool for this. So why we decided to go there? So when you take some unstructured data, for example, images, to be able to build some AI model on top of it, or machine learning model, right? You need to unite the binary data and metadata with the labels and with some other metadata together, prepare and then split and then pass this data to your train pipeline. So this is the first problem. So how to join this data? For small amount of data, it's not a problem. But just imagine that you have some images or videos that are generated every day, and they are added to your warehouse every day. And also you have the annotation for the data, and the annotation is also like not always correct, right? So you can generate annotations, so you can annotate data by yourself, for example, and after some time you can update annotations because you find some I don't know, problems with that. So and we have like situation when we, at the one hand, we have a lot of data that is changing, like data itself. And also we have the annotation that are changing. And we need to somehow to navigate what versions of data and what versions of annotations should be like stick together to train my model at this specific time for my project. So this is like first problem. The second one is the amount of data. Again, specifically in video analytics and computer vision, their like data sets are pretty heavy, right? And when you do some operations with that data, you don't want to copy and duplicate the data. So okay, so you cannot like download a few terabytes of data on your laptop and process it. You need to use cloud infrastructure to do this, and you don't want to like move those terabytes of data back and forth because it's expensive and time consuming. So how can we do all those operations on top of data without the copying and without duplicating data? So this is like a second use case we're focusing and thinking about. And the third one is how to manipulate data sets together with like different AI processing tools and LLM models that can generate embeddings, generate descriptions, do some kind of pre-labeling right before, like in automated way, and how we can like do different operations one by one, and like not lost in all those versions and artifacts that are generated along this site. So these three use cases we had in mind, and this is how we can come up to data chain. So data chain is the AI data warehouse to enrich, transform, and analyze unstructured data. It's open source tool, like iterative, like build some SaaS solution on top of this open source library, but it works like pretty well for like as an open source version, and you can try it. And actually, the guys, the DSC team, they're really cool guys. And if you can go to their GitHub and put a start to them, so they'll be happy. And this is the small good thing that we can help open source today. So please, if you have time and you have phones, just say them your warm hello. So let's dive into the data chain a bit, how it works and what functionality it has. I want to show you three use cases with different modalities of data that maybe like get you some understanding how it works, and you'll have ideas maybe how you can use this tool or another tools for unstructured data in your projects. So like functionality inside data chain, they covers like multimodal data versioning, right? It's like Python friendly, and all operations actually is a Python scripts, very similar to Pandas operations. And yeah, and you can apply different APIs and LLMs to enrich your data sets. How it works? So imagine we have our data stored in cloud, in S3 buckets or whatever. There can be different structure of those data, and imagine there are like terabytes of data, there are a lot of them. So what data chain actually start with is just to create the data chain object, which is a like table of pointers to the files stored in cloud. This is like pretty simple. We can keep this table of metadata some SQL like in Postgres or in SQLite tables, so they are pretty small. And when you put this table into a standard relational database, you can run a lot of operations on top of that, right? You can do filtering, sorting, you can merge different tables, and this is like where this is actually the basis of operations for data chain. So data chain provides you a Pythonic API, but under the hood, actually, it transforms this API, your like commands into SQL scripts and run operations like in SQL layer. So we created this table with pointers, and we also can add some metadata to this, right? And we can add like technical metadata, like as like file names or size of the images, and also we can add like labels, annotations. We can it can be like a simple labels, as for example, gender here is a man, women. So it's just some string, or it can be JSON, or it can be like nested object inside, or it can be some embedding, right? So we can just calculate embedding for our file and add it as a metadata to this pointer. So this is how like data chain unite like objects and metadata. And the third step is that we can now all these tables in data chain we can version, we can run different operations on them, and yeah, and actually how it this is how it works. So let's jump into use cases. First use case is PDF processing and LLM evaluations. Just a few examples of code and the results. So the first example is how data chain object is created. It's just you can create it from any bucket in cloud storage or from local directory. So just from storage, for example, we pass the URL to the storage, and data chain just run command script to create some index for that data storage, right? And generate this table with for all our data set. So and you see that to show this data set a few lines, it's the show command, very similar. Actually, the code is was running in Jupyter Notebook, so you can imagine that you can do it in interactive way. It's pretty user-friendly. So, okay, let's go to the next step. We need to process documents. For example, generate, recognize the text, right, and attach text chunks to our PDF files. There are like different methods inside data chain. For example, the .gen method can apply our process PDF function to every file that we have in our data chain. Yeah, and return like results as a chunk object in this case. And chunk object actually is a pydantic object with like type with annotated types that like easily to manipulate later. Okay, so after we like create all this stuff, we can run different processes, and for example, we can run some. In this case, is what we are doing here. Okay, we ask Mistral model to generate some prediction, some annotation for our files, and actually, what data chain like provide is that it returns pydantic object with a clear structure, and because it's pydantic, it can automatically check format of the returning objects. So it's pretty handy with when you work with LLMs and try to get some structured output from LLMs. So this is also a nice feature. So actually, this is how it works with for LLMs. You can organize all your prompts and examples, for example, Q&A pairs that you use to train LLMs. You can attach to them a lot of additional information labels that you can use later to filter and sorting. And we'll just talk about the filtering in next cases. The second case is a computer vision. Specifically for fashion, based on fashion data set, fashion product images. And we start in the same way. We just create the new data chain, in this case from the data set that was previously saved. So when you create data chain, you can save it. You can save the data set from the data chain. So it's like, I'll say, some kind of snapshot of your data chain. And you can create the data chain from the previously saved version. You can specify version that you need. And you also can list all versions of the data, for example, this fashion product images data set that you have in your system. And you get back the same table. So how filtering and sorting works? It's actually very similar to what we had in Pandas with a similar API and methods like select. We just name a list of columns from our data chain that we want to return. And we can attach some filters and ordering, sorting, whatever. So with pretty simple expressions. And this is how you can actually to prepare data set for training with a specific characteristic. Let's say if you have data with cats and dogs and you want to only dogs, so you just apply simple filter. If you want to add data from, I don't know, ImageNet, right? So you can just create the new data chain, filter that specific subset of data from that data set, and you later join with our cats data set. So, and you are working on this metadata level in a pretty simple API. Okay, what else we can do with this? Actually, we can, if we are talking about machine learning, right? So usually the workflow is we prepare data set, we split it to training and validation subsets, and then we can train our models. This is actually what we can do with data chain. So here the example of simple function, train test split. It's suboptimal, but simple and easy to explain how it works. So we prepare some kind of function that can operate on columns inside our data chain and just map this function to every object that we have in the data chain. So this .map method actually apply this train test split to specific column name file path that is we mentioned in params. Argument, and also usually we specify output type, whether inside this map method or inside function that do this processing. So we split it, and now we can do training, or we can do to run embeddings, for example. In this case, the pattern is the same. There is a function that takes our file, and a data chain provides for each object in data chain, it provides the .read method that can automatically read content of your file from the cloud, right? And stream this object to the running process. And this is how you can generate embeddings. And this is how you can actually bring the data and put it into the training pipelines. So in this case, we just calculate embeddings. And because embeddings with large models, visual or LLMs models, takes time and takes resources. So inside data chain, I'm not sure it's available in open source version. Anyway, so the idea that you can just distribute these processing jobs into cluster and use your GPU cluster to speed up the process of generating those embeddings. So now, okay, let's go to the training, how to train. In this example, we just used like standard PyTorch pipeline to train model. And in PyTorch, we have PyTorch dataset and data loader, right, that we use in training script. In this case, data chain can just convert or create dataset object that we can put into data loader and provide this data loader to our standard PyTorch script. So easy. What we can do with else with embeddings, how it can be like useful. There are some additional scenarios from the companies I was working with specifically for computer vision is how to find similar objects and how to remove redundant objects that waste of the time and resources when you want to run computer vision training. So there is an interesting paper, I forgot to add it to this presentation, that the guys research the approaches and methods how to reduce data set size for computer vision training jobs. And they can, for example, for standard like ImageNet data set, that reduce it twice, right, and got almost the same model quality results, quality metrics. And it's like speed up the training twice, it reduce the cost for training, and it's pretty smart way, I think, that to deal with large data sets. So data chain also can help with this, right? If you have embeddings, we can generate do some kind of similarity. We can cluster objects and do deduplication. It's not built it in the data chain, this functionality, but we just use like a separate function that that data chain run with those map and generate gen methods. So this is about computer vision like with the static images, but it also works in the similar way for video analytics. And so here I was working with video data sets from Kinetics, and we try to split videos to frames, also extract the most relevant, not relevant actually, but diverse frame from the video using different algorithms, and train models based only on that small subset of frames. And in this case, we also had some challenges how to deal with annotations, because for videos you have not just one label in your annotations, but you have frame. In frame you have detected objects, and every detected object consists of maybe key points or a bounding box, right, and some labels, or it also can have some key points for post-estimation data set, for example, in our case. And we also come up with simple data model, pydetic models for our data, and applied it with the data chain. So we using data chain, we split it all videos to frames, generated annotations in the data model in the format that we want to work with, and yes, and just created the data set for our videos, and then can train, can visualize, because everything in standardized way in the pydantic as with in format that we want to have, we can prepare a lot of utility functions and method to visualize, to process, to generate some analytics on top of it. So, and it's pretty handy and efficient. Yeah, so you can visualize it. So to summarize, let's say that the way the data chain approach these problems and unstructured data management is they help to manage and version data, both data sets, binary data, and annotation metadata level. So it can efficiently parallel processing on millions of files using your on-premise cluster with GPU or cloud GPUs, and actually eliminates a lot of scripts that you will run and like write by yourself. So it's already a data chain, and it can help just to save your time. So this is ideas and like results of my like R&D and collaboration with the guys during the last 6 months. And again, please give them a star if you like them. Please try and give them feedback. They will happy to like hear what can be improved and how you want to use it. And I think that's it from my side. Thank you very much, and I will be happy to answer your questions.
So it's time for your questions. I hope you have some. Do we have some questions for Mikhail after this session? Yes, please, here. Could you please just wait a second for the microphone? Thank you.
Hey, thanks so much. What's the level of complexity that you can have in an image? Is it sort of cats, dogs, or can you get really complex sort of text, sort of feature sets?
What do you mean by complexity?
So, for example, okay, you showed a couple of T-shirts, things like that, right? Could you look at a really complex scene, for example, a manufacturing scene or something like that?
Yes, yeah, of course. We just use this simple just because it's smaller and easy for demos, yes, but you can do with any images you have.
Okay, thank you.
Thank you for the question.
Yeah, we have some more time. Yeah, here we have another question.
Hi, Mikhail.
Good to see you.
Good to see you too. Tell me, how do you handle data of different sizes? So, for example, if you have videos which could have different lengths or even different resolutions, does that represent a problem into structuring them into a single data frame or data? What's the term? Data chain.
The great question. Actually, like because you can attach the information about length of the duration of the videos, right, as a metadata column, and use this information later, for example, to extract the relevant frames. And you can also, like for example, FPS for the video also you save as a metadata, and the both information like efficient to extract frames later.
That makes a lot of sense. Thanks.
Thank you.
Right.
Still time. Another question, maybe yes, also here in the third row.
Hi there. I wanted to ask about multimodal data. Can it handle, for example, if we have a visual image, a thermal image, and a LiDAR image of something, can we place them in the same data set, same data frame, and then work on them through models and stuff like that?
Yes, easily. There is a separate tutorial about multimodal data. You can find it in the repository. But the idea is like, for example, for that video data set, for example, when I split it into the frames, like every row in the data chain is like a separate frame, right? But it can be a separate file, video, image, text, and if you attach, for example, some ID, like object ID, right, to every of this file, then you can aggregate them. For example, like select only IDs, object that you need by ID, right? Or you can then use the processing function that will extract all multimodal data for specific ID, do some like processing, and then maybe return some like joint object or embeddings, whatever. So yeah, it works with multimodal as well.
Thank you very much.
Thank you for the question.
Maybe we have some more questions. We have some more time if you would like to ask something. Okay, well, probably the audience will find you here
Thank you very
during
much.
the conference.
Thank you very much for your attention.
Thank you.
Bye.
And this is a certificate of appreciation from the organizers. Thank you very much.